The solubility rules are as follows. Things that are always soluble, and this is in an aqueous solution or a water solution. So any of the alkali metals, that's in the first column on the periodic table, and they're listed here: lithium, sodium, potassium, rubidium, cesium, ammonia, nitrate, chlorate, perchlorate, and acetate are always soluble. Generally soluble means that they could be soluble, they're mostly soluble, but there are some exceptions. So chlorides, bromides, and iodides are always going to be soluble unless we have silver, lead 2, or mercury 1, and then they won't be soluble. Fluorides are soluble except if they're bonded to calcium, strontium, barium, lead 2, magnesium. Sulfates, and I'm not going to read all these to you, you can look at them. And then our things that are generally insoluble are oxides, are hydroxides. Hydroxides and oxides will be insoluble except for alkali metals, ammonia, somewhat soluble if we have barium, strontium, and calcium. And then the carbonates, phosphates, sulfides, sulfites, oxalates, and chromates are going to be insoluble unless they're with that group of alkali metals or ammonia. So what that means to us is that if we need to make a prediction and we see something like AgCl, and I want to know is that soluble or not. Well, if I look up at my solubility rules, so if we look up at the solubility rules and we see that chlorides are soluble except for silver, lead, mercury. So our silver chloride down here would be insoluble. Mercury. So our silver chloride down here would be insoluble. Or if it was formed in a reaction, it would make a precipitate. And so you have to look at each of the ions to see how they fall into our solubility. So if we had something that had any of these things that are always soluble, it'll be soluble. If we have the stuff that is generally, then you just have to look at the chart and see where it falls. Now, we will do this a great deal in our precipitate lab